Good morning, students. Next our experiment is Ohm's law. First, Ohm's law statement. Ohm states that at a constant temperature the current flows through a conductor is directly proportional to potential difference between the two ends of the conductor, or otherwise one more definition is at a constant temperature voltage is directly proportional to current. Okay, so this is a simple statement. You remember this experiment is very small experiment here. So we need to prove V is directly proportional to I. We have one condition to satisfy this Ohm's law at a constant temperature. At a constant temperature only V is directly proportional to I, or otherwise temperature is not a constant, in the sense V is not a directly proportional to I. Okay? If any case temperature is constant, then we can get it V is directly proportional to I. If temperature is not constant, then automatically the conductor resistivity will be changed. So whenever temperature is increases, automatically the flow of current will be decreases in conducting material. For a semiconducting material, if temperature increases, the flow of current also increases. Why? Because you remember it's a small observation. If any case temperature increases, there is a collision process in conducting material. So due to that collision process, automatically there is a friction in between the atoms. Because of that, automatically what will happen? The resistivity will be increases in a conducting material. Due to that, automatically flow of current will be decreases in a conducting material, okay, especially in electrical system. But in a semiconducting material, we are taking whatever it may be electronic devices. In electronic devices, we are taking semiconducting materials. So that semiconducting material temperature increases, semiconducting material flow of current also increases, because there is no any collision process in semiconducting material, because the atoms are little bit high distance compared to conducting material. Due to that, there is no any collision process in semiconducting material. Because of that, semiconducting material flow of current will be increases if temperature increases. If temperature increases, conducting material conductivity will be decreases. Because of that, whenever temperature changes, then automatically flow of current will be changed because of the resistance. That's why at a constant temperature only Ohm's law will be obeyed. If temperature is not constant, Ohm's law will not obey. So here you remember I have taken a small circuit. So here the power supply I have taken 10 volts. For this 10 volts only I will be going to calculate theoretical calculation. Here the resistance I have taken 1 kilo ohms. So you observe here in this particular kit, you remember here maximum 20 volts only we have a DC power supply. So we are getting in laboratory only AC. That AC is converted here, one rectifier is there, that rectifier will be converted into DC. That DC power supply I have connected here input terminals. Okay, whatever the resistance I have taken here, that resistance is 1 kilo ohms resistance only. Here we have so many resistance, 1, 2, 3, 4, 5, 6. So 1K, 2K, 3K, 4K, 5K, 6K. So if any case we need to increase the resistance value, so these resistances only we are going to connect here. But here I am going to take only 1 kilo ohm resistance only. And here I have connected one ammeter here in series with this resistance. And other than these entire resistance we will not consider. I have taken only one resistance. Then I am going to connect from here to directly to the power supply. Okay, so the same circuit I have taken for here to measure the current by using a milliammeter. That one is 0 to 50 milliammeter I have taken here, 150 milliammeter. Here I have taken one multimeter to measure how much of power supply I am going to take here. For that purpose only I have taken one multimeter here. And you remember here I have done a theoretical calculation. I have taken a 10 volts power supply, resistance 1 kilo ohms. Already I said in the circuit also I have shown. So here I is equal to V by S formula according to Ohm's law. So at a constant temperature, according to Ohm's law, I is equal to V by R. Voltage source I have taken 10, resistance 1 kilo ohms. I have substituted that value 10 by 1 into 1k in the sense 1000 ohms I have substituted here. Then I got 0.01 amperes. So that values I have replaced here in a theoretical calculation. Theoretical voltage, power supply I have taken 10 volts and current 0.01 amperes, and here resistance I have taken 1 kilo ohms. Then we will go to observe how much voltage we are getting across the resistance and current and what is the resistance value we will be going to observe here. Then I am going to turn on the power supply. You observe here. So here I am going to check input supply voltage. Here you remember in series with this resistance we got 11 milliamperes, and I have connected one voltmeter DC voltmeter across this resistance. So what actually we got here, 10.36 voltage. That one only a practical voltage across the resistor. That one is 10.31 volts. So theoretically source voltage we have taken 10 volts, but across resistance we got voltage is 10.31 volts. Okay, so theoretically and practically verified and proved.